Hello guys, welcome to Sendimi's online tutorials. On today's episode, we'll be discussing on frictional force. Welcome back. So I know that we must have seen several problems where a body rests or glides on a surface that exert force on that body. Whenever two bodies interact by direct contact of their surface, we describe the interaction in terms of what constant forces. Now, friction is very important in every aspect of everyday life. Like, you can't just do without it. You're sitting down is friction, you holding that phone and watching this video is friction. You know what I'm saying? Even walking to go get that cup of water you're about to go get, I don't know if you're getting it, but you will go get it in a jiffy. It is friction that makes you walk to that kitchen or to walk to your store and get that water and drink. So now friction is kind of pretty important, and we have to just study it. So now air drag, we know that is a frictional force that stops a body, that opposes a body in motion in air. And it also reduces economy of fuel, automotive fuel economy, but it makes parachute work. So friction is very, very important. So now we'll talk on kinetic and static friction now. Now when you try to slide the heavy box across the floor, the box doesn't move at all unless you push it with a certain minimum force. Then the box starts moving. Now and usually keep it moving with less force than you needed to start it with. Like for instance, if you start the box with a force of 500 Newton, you might keep the box moving with a force of 430 Newton. You see that it is not the same, it is quite lower than what you started out with. So once you start moving, it reduces. Let us assume that this is the box that we want to study and this is the ground. So now this is the width, mg. This is the force, push or pull. We have the normal reacting force here, and we have the what? Frictional force here. Let us say now we have something we call a contact force. Let us say we have contact force or forces at this point. Now, if the surface is perpendicular, surface is frictionless, then our force is equal to 0. But that doesn't mean the fact that our normal reaction will not go through. If it's frictionless, like if we have let us say we have lubricant here, this is our friction will begin to equal to 0 because there's nothing that will be dragging it back. But our normal reaction is still going to maintain its point. Now, the kind of friction that acts when the body slides over a surface is what we call kinetic frictional force. The magnitude of this kinetic frictional force usually increases when the normal force increase. So now what it means that, for instance, this is what we have. We have our F K is equal to mu sub K multiplied by the normal reaction N. This is the magnitude of the kinetic friction force. Now, friction force may also act when there is no relative motion, like this is just left here. Let me give you an analogy. Like, let's say you are trying to push this box. So I said earlier, you try to push it, but it's not going. Now, at the point where that force is not going, the static friction is equal to the amount of force that you are applying. Like, as you try to push it, it's also exerting an equal and but opposite force to your hand, so it is not moving. But it gets to a point where you exert a force, on the body that is greater than the mass of the body multiplied by its kinetic friction. Once it gets to that point, the box can be able to move. So now the force that stops that box from moving or puts it in static position, what we call static friction, and it is multiplied by mu sub s multiplied by the normal reaction N, and the magnitude of static friction. Let us Let us have an example. The example says you are trying to move a 500 Newton crate across a level floor. To start the crate moving, you have to pull with 230 Newton horizontal force. Once the crate breaks loose and starts to move, you can keep it moving at a constant velocity with only 200 Newton. So our question is, what are the coefficients of static and what? Kinetic friction. Now we know that the crate is in what? Equilibrium, whether it is at rest or moving at a constant velocity. So we are going to use what? The first law of what? Newton, or Newton law of motion. The first one. Let's say this is the box. And then say this is you trying to push it. That's the bad guy. Long time. I'm trying to push the box, but it just isn't working until it breaks loose, and you have to maintain a force of 200 Newton to keep it going. So now we use Newton's first law, and if you know, there are 4 forces acting on it. Let me draw a free body diagram. So this is D. Sorry, that represent it as a particle. The weight 500 what? Newton. The normal reaction N, and the force or the tension at which you apply 230 Newton. And this is Fs. This one is when the body is about to move. It's just about to move, like the brink of movement. The static friction here is maximum. Do you understand what I'm saying there? But when the body moves, let us say the body has moved now. So free body diagram for the body moving. So the particle is for N. This is for 200, and the body is moving. So the force will change. But the weight is still 500 Newton, as you know. So this one is equals to force. Kinetic frictional force. So now there are 4 forces that it is applying. So we have the upward force, which is the normal force exerted by the ground, the tension to the right exerted by the rope, and a friction force to the left exerted by the what? Ground. Just before the crate is about to move, let us get the sum of forces on the x-axis. This is for when the crate is about to what? To move. We have T plus opposite negative of what? Max. So our F max is equal to our what? Tension, which is equal to what? 230. So as I said earlier on, when I was explaining, I said the static friction will still be equal to the force at which you apply. So it just can't move anyway, because you are pushing it, like it's the same force until you overcome the force, and that is when it's about to move. For the horizontal, you see our N, it is up plus negative 500. So our N is going to be what? 500 what? Newtons. Now to find the value of our mu s, which is the static, remember we say our s is equal to mu s, and to get mu s, we say it is equal to fs over what? And we say our fs from here is equal to what? 230 over normal reaction, which is 500, which is not equal to 0.46. Now this is for when it is about to move. Now when it is moving, sum of forces on the x-axis, we say it is T plus negative Fk equals 0. So we know our Fk to be what? T, and is equal to what? 200 what? Newton. Now for the sum of forces on the y-axis, we say it is N plus, which is equal to 0. But our N is equal to W, which is still equal to 500. We got our Fk, we got our W, just divide. Now for our mu k, we say it is fk over what? N, and our fk is what? 200 over 500, which gives us 0.4. With that being said, I'll be drawing the curtain for today's episode, and the next video we'll be discussing on the dynamics of circular motion. So stay tuned. I'll be dropping a comprehension so that you can practice this. Bye.